Mechanism of SN2. Mechanism of SN2 reaction. The mechanism of SN2 reaction involves the simultaneous formation of the carbon nucleophile bond and the breaking of the carbon halogen bond. Okay, this is the transition state. This is the transition state in which bond forming, new bond formation and old bond breaking takes place simultaneously. Okay, SN2 reaction, the nucleophilic carbon bond formation and carbon leaving group bond breakage happen simultaneously. This is the transition state. In the transition state, the carbon is partially attached to both. The central carbon is partially attached to both nucleophile and the leaving group. Okay. Then stereochemistry, the SN2 mechanism always proceed through rearward or backside attack of the nucleophile. The nucleophile will attack from the backside. Okay. On the substrate, this process results in the inversion of the relative configuration going from starting material to product. Whatever the starting material, this is the starting material. Here the bromine is there, but in the opposite direction the nucleophile is attached to the carbon. That's why the product form will be in inverse product is formed, and this inversion is known as Walden inversion. Okay. In the previous year, internal examination, in the internal this question arises. Then solvent, polar aprotoic solvent without OH favors the SN2 reaction. The polar aprotoic solvent without OH favors the SN2 reaction. Example of polar aprotoic solvents are acetone, dimethyl sulfoxide, NN dimethyl formamide, etc. These solvents favors the SN2 reaction. Then we discuss the comparison between SN1 and SN2 reaction mechanism. Okay, the SN2 reaction involves in one step. The mechanism follow one step, but SN1 reaction two-step mechanism. But SN2 substitution, nucleophilic substitution bimolecular. It is a bimolecular reaction. It is unimolecular. So, nucleophilic substitution, one tends to unimolecular reaction, and the product formation takes place by transition state. Here the transition state is there, in which old bond breaking and new bond formation in the transition state, and in SN1 reaction the product formation takes place by carbocation intermediate. Here carbocation will be formed, okay, by the intermediate. Carbocation intermediate, then no carbocation rearrangement in SN2 reaction, but here the carbocation rearrangement is there. In SN2 reaction is favored by polar aprotoic solvents. Here the reaction is favored by polar protoic solvents. Okay, then it is the reaction is suitable for methyl halides. For SN2 reaction, the reaction is suitable for methyl halides, and for SN1 reaction, it is suitable for tertiary alkyl halides. And the reactivity of SN2 reaction is Rx, that is methyl group greater than primary, then secondary, then tertiary. Okay, but it is in SN1 reaction, the reactivity order is just inverse. The tertiary is greater than secondary, then primary, then methyl. Okay, then mechanism is favored when nucleophile is an anion. In case of SN2 reaction, the mechanism is favored when the nucleophile is an anion, but here the mechanism is favored when the nucleophile is neutral. Okay, here the inversion, the reaction velocity depends on the concentration of the nucleophile. The reaction velocity is independent in the concentration of the nucleophile. Here the racemization occurs, but here the inverse configuration occurs. This is the comparison between SN1 and SN2 reaction. Another comparison is there, SN1 and SN2 reaction. It is a two-step. SN1 is a two-step reaction. SN2 is a one-step reaction. Molecularity unimolecular. It is bimolecular. Only substrate is involved in red determining step, but here both substrate and nucleophile are involved in the reaction in case of SN2. But in case of SN1, only the substrate involved in the red determining step. The kinetics is first order, here it is second order. Stereochemistry, racemization, here complete inversion is there. Racemization means the ratio. In the ratio 30-70 or 70-30, the product is a racemic mixture, but here the complete inversion occurs. Okay, then the stability of carbocation, effect of substrate structure on the red. The stability of carbocation is tertiary greater than secondary, then primary, then methyl in case of SN1. But here just opposite, methyl greater than primary, then secondary, then tertiary. Okay, then solvents, polar protic solvents like water favor for SN1, but polar aprotoic solvents without OH favors SN2 like acetone, etc. Then nucleophilicity and concentration of nucleophiles. Weak nucleophiles of low concentration too can make the reaction to occur. Nucleophilicity, weak if the nucleophile is very weak, then also the reaction can occur. Okay, in low concentration also, but in case of SN2, the strong nucleophiles repair in high concentration. Okay, these are the difference between, or these are the comparison between SN1 and SN2 reaction. Then factors affecting SN1 and SN2 reaction. What are the factors that are responsible for favor SN1 and SN2 reaction? The rate of an SN1 and SN2 reaction depends upon 4 factors. There are 4 factors which are responsible for SN1 and SN2 reaction. Number 1, the nature of the substrate. Okay, what is the type of substrate? It is methyl or primary or secondary or tertiary alkyl halide. Okay, then the power of the nucleophile. The nucleophile is strong or the nucleophile is weak, or the concentration or is more or the concentration is less about your nucleophile. Then the ability of the leaving group to leave. In case in both SN1 and SN2 reaction, the leaving group is halide, halide, bromide, that may be bromide, chloride, iodide or chloride. And what is the ability of leaving group to leave? Okay, then the nature of the solvent. What type of solvent we are used? Protoic solvent or aprotoic solvent. These are the 4 factors that are responsible for both SN1 and SN2 reaction. Okay, first we discuss about the nature of the substrate, the alkyl halide. This is the substrate molecule, the alkyl halide. In SN1 and SN2 reaction, the substrate plays the most important part in determining the rate of the reaction. Highly substituted alkyl halide, the substrate form a more stable carbonium ion. The 3rd degree alkyl halide undergo SN1 reaction with more Eg. Okay, then methyl and primary alkyl halide undergo SN2 reaction with Eg. Okay, secondary alkyl halide react more slowly. Then tertiary alkyl halide do not undergo SN2 reaction because of steric hindrance. What is steric hindrance? Any one of you, what is steric hindrance? The methyl group is a bulky, is a large group. They hinder, they oppose the nucleophile to attack the central carbon. Okay, for example, the hydrogen is a very small atom, but the methyl group is a larger enough, and it will provide the steric hindrance. The nucleophile cannot reach at the central carbon because they make the place more crowdy. They make the place more crowdy. That means you are at Gopalpur and the function is there. Okay, and at the time of any type of function, Durga Puja or Kali Puja, it is more crowded. You cannot enter into the or get past through the highway. Okay, it is more crowded. Just like it is a Boki group. The methyl group is a Boki group. It is a large group. Okay, the size is larger, but hydrogen atom is a small atom. Okay, and the nucleophile can pass to the central carbon atom. Here the steric hindrance have smaller effect, but in case of Boki group, the steric hindrance is larger enough. Okay. This is about your steric hindrance. For the steric hindrance, the methyl and primary alkyl halide undergo SN2 reaction. Okay. And the secondary alkyl halide react more slowly, and tertiary alkyl halide, the tertiary alkyl halide are Boki enough. They are larger, and the nucleophile cannot enter into the central carbon. That's why for SN2 reaction, the tertiary alkyl halides it cannot undergo SN2 reaction. It has been steric hindrance caused by Boki R groups makes nucleophilic attack from the backside more difficult, slowing the rate of reaction. Okay. Can you understand, all of you? The methyl group or ethyl group are larger groups. Okay. And the nucleophile cannot pass through to the central carbon. That is known as steric hindrance. Okay. It has been studied in +2 level also. Then nature of the nucleophile. A nucleophile with a negative charge is always more powerful than its conjugate acid. Acid, conjugate acid, base, conjugate base. If the acid is strong, then its conjugate base is what? Weak. If the base is strong or weak, its conjugate acid is strong. Okay. For example, hydrochloric acid, it is a strong acid or a weak acid? Hydrochloric. Strong acid, and its conjugate base is Cl minus conjugate base. Okay. Nature of the nucleophile, a nucleophile with a negative charge is always more powerful than its conjugate acid. The OH minus is more powerful than H2O. Okay. OH minus is a base, and H2O, it is strong base. The OH minus is strong base, and its conjugate acid is water, H2O. That's why it is weak. Water is a very weak acid, and its conjugate base is OH minus, it is very strong. Okay. Likewise, NH2 minus is a more powerful than NH3, and CH3O minus is more powerful than CH3OH, etc. The weak nucleophile favors SN1 mechanism, and the strong nucleophile favors SN2 mechanism. Okay, you have to remember the weak nucleophile. Weak nucleophile means, what is weak nucleophile? Nucleophile is always negatively charged. Okay, if the negativity is very small, that is known as weak nucleophile, that will favor SN1 mechanism. But the strong nucleophile favors SN2 mechanism. Tapre nature of the leaving group. The nature of the leaving group has the same effect on both SN1 and SN2 reaction. The better the leaving group, the faster C plus can form, and hence the faster will be the SN1 reaction. Okay, the leaving group means it may be fluorine, chlorine, bromine and iodine. All the halogen atoms are leave from the halide, from the alkyl halide. Okay. Then the nature of the leaving group has the same effect on both SN1 and SN2 reaction. The better the leaving group, if the leaving group is better, the faster C plus can form. Okay. If we compare fluorine, chlorine, bromine and iodine, which will leave faster? Which will leave faster? The iodine, then chlorine, then bromine, then fluorine. Okay. The better the leaving group, the faster C plus can form, and hence the faster will be the SN1 reaction. The leaving group usually has a negative charge. Example, iodine is a good leaving group. If we now discussing about if we compare fluorine, chlorine, bromine, iodine. Okay, if we compare fluorine, chlorine, bromine and iodine, which atom will leave faster? Iodine, then bromine, then chlorine, then fluorine. Okay. Yes, iodine is a good leaving group because iodide is a non-basic. The hydroxyl group is a poor leaving group because hydroxide OH minus is a strong base. Okay. Then the nature of the solvent. There are three classes of organic solvents. One is protoic solvents, then polar aprotoic solvents, then non-polar solvents. The protoic solvents, examples are OH minus and NH2 groups. The polar aprotoic solvents are OH minus contain strong dipoles but no OH and NH2 group. It contains no OH and NH2 group, and non-polar solvents are hydrocarbons. Non-polar means chloroform, acetone are the examples of non-polar solvents. Okay. Then polar protoic solvents like water and ROEs favor SN1 reactions because the ionic intermediates, both cations and anions, are stabilized by solvation. Solvation means the interaction of solute with solvent. That is known as solvation. Okay. Then polar aprotoic solvents favor SN2 reaction because nucleophiles are not well solvated and therefore more nucleophilic. These are the examples. Solvents, different type of solvents. Polar aprotoic solvents, examples are dimethyl sulfoxide, dimethyl formamide, acetonitrile, hexamethyl phosphoramide. These are the examples of polar aprotoic solvents. Then polar protoic solvents are water, methanol, ethanol, ammonia, tertiary butanol, acetic acid, etc. Then we discuss structure and uses of alkyl halides. Different examples are in your syllabus. All these are present in your syllabus. Okay, according to the syllabus, this slide has been made. Okay, the first one is ethyl chloride. Ethyl chloride. This is the example of ethyl chloride. 2 carbon are there. Then chloroethane, ethyl chloride. Ethyl chloride, this is one chlorine atom is there. Chloroethane or monochloroethane, commonly known by its old name ethyl chloride, is a chemical compound with chemical formula C2H5Cl. Once widely used in producing tetraethyl lead, a gasoline additive. Or chloroethane is produced by hydrochlorination of ethene. Hydrochlorination of ethene. This is the method of preparation of ethyl chloride. C2H4 plus HCl, C2H5Cl. And uses, the major use of chloroethane was to produce tetraethyl lead, TEL, an anti-knock additive or for gasoline. It is used in the production of cellulose, dyes, medicinal drugs and other commercial products. Cellulose. What is cellulose? Cellulose are used for cellulose. Cellulose are also present in the timbers. Are we able to digest cellulose? Ame cellulose digestion kori we are not able to digest cellulose. Okay. Cellulose dyes means colors, medicinal drugs and other commercial products, and as a solvent and refrigerant. It is used as a mild topical anesthetic. It has been discussed, general anesthetic and local anesthetic. Okay. Topical anesthetic. Topical means topical application. The various routes of drug administration. What are the different types of drug administration routes? Parenteral, oral, topical or local application. Topical means on the skin, on the localized area. These are known as topical application. Okay, and the ethyl chloride is also used as topical anesthetic. Topical anesthetic. Okay, means it can be locally applied. Locally applied. तुमर जो दांत को कौन उपुड़ीबार अच्छी से जगह लगे दांत उपुड़ी पार तुमको पेन हम ना. ओके, टॉपिकल एनास्थेटिक टू नम द स्किन प्रियो टू ईयर. जमती कि तुम कान फुड़े टाइम रे लोक कान फुड़े तो पुओ मैंने फुड़े ना झील तुम सब फुड़ौच. हाँ, जड़े जड़े फुड़ौ. एनी वन ऑफ यू तुम क्लास रे कई भी अच्छा माने पुओ पिला कान फुड़े दिवा. कान फुड़ेले कौन हम पेन हम ना. तेणु आम जब टॉपिकल एनास्थेटिक दबा लोकल एनास्थेटिक आम दौचे कान फुड़ा होची आमको आउ कौन कष्ट हम ना पेन हम ना. तुम फुड़ेच तो यस सैला नहीं. Then chloroform. The second compound is chloroform. Okay, chloroform or trichloromethane. Chloroform or trichloromethane is an organic compound with formula CHCl3. Trichloro, 3 chlorine atoms have been attached. Okay, has been attached. It is a colorless, sweet-smelling, dense liquid. It is a precursor of polytetrafluoroethylene. It is also a precursor to various refrigerants. In industry, chloroform is produced by heating a mixture of chlorine and methane. At 400 to 500 degrees Celsius, a free radical halogenation occurs, yield the chloroform. This is the chemical formula of chloroform. And what are the uses? It is a solvent for liqueurs, floor polishes, resins, adhesives, alkaloids, fats, oil and rubber. Chloroform is used in making fluorocarbon 22, a refrigerant. It is also a refrigerant. Chloroform is also used to extract and purify penicillin. Penicillin. What is penicillin? Who can tell? What is it? It is an antibiotic. What type of antibiotic? Beta-lactam antibiotic. It is a beta-lactam antibiotic. Okay. Extraction and purification. Then chloroform is used for extraction and purification of alkaloids. What is alkaloids? Alkaloids. It is a secondary metabolites. It is a secondary metabolites. It is metabolized by plant or animal. आम एनिमल पाखु पाचे ना प्लांट्स मान पाखु पाचे. What are the primary metabolites of plant? What are the primary metabolites of plant? Carbohydrates, proteins, fats, all these are primary metabolites. But alkaloids, glycosides, resins, all these are secondary metabolites of plant. Okay. Chloroform was popular as an anesthetic from the mid 1800 to around 1900. Okay, it is a very popular anesthetic, general anesthetic. Chloroform is a general anesthetic. Loss of consciousness, reversible loss of consciousness. Then tetrachloroethylene. This is the structure of tetrachloro. 4 chlorine atoms are attached to the 2 carbon, bonded with double bond. Carbon-carbon double bond. It is a volatile, chlorinated organic hydrocarbon that is widely used as a solvent with the chemical formula C2HCl4. It is non-flammable liquid at room temperature, evaporates easily into the air and has a sharp, sweet odor. It is prepared by thermal decomposition of hexachloroethane. Okay, this is hexachloroethane. It will be decomposed to tetrachloroethylene plus Cl2. Uses. Why you are making sound? Listen. One time you have to listen. It will memorize in your brain. Carefully you have to listen. Tetrachloroethylene is an excellent solvent for organic materials. It is a solvent. It is a solvent. Water is a what? Water is also a solvent. Okay. Tetrachloroethylene is an, what is a polar solvent or non-polar solvent? Water. Huh? Previously कहली जे solvent विषय रे एते सारा कहली. Water is a polar or non-polar solvent? Huh? Polar solvent na? Non-polar solvent example? Chloroform. How? Acetone. These are the non-polar solvent. Okay. Always remember, water is a polar solvent. It is widely used in dry cleaning. Dry wash होउछि ना, dry wash. तमे कोन कॉस्टली ड्रेस एंड कॉस्टली ड्रेस सब निजे सफा करनो, ताको ड्राई वाश करियो में दोजे कि नहीं? And it is a solvent. The tetrachloroethylene it is a solvent used for dry cleaning. It is also used to degrease metal parts in the automotive and other metal working industry. We are using grease to lubricate the machinery parts, to lower the friction. आमे सब मशीन में कोन ग्रीस सब यूज करने काहे यूज करछे फ्रिक्शन को कमेवा पई वर्क एफिशिएंसी को बढ़ेवा पई तो डिग्रीज हमको करिया पई पड़बो ताको सब वॉश करिया पई पड़बो दिस इज द सॉल्वेंट यूज्ड टू डिग्रीज okay it appears in a few consumer products including paint and spot removers if any type of spot is there तमरो कोन होची डिफरेंट कलर्स तमे कोन केक बर्थडे रे तो सब केक खाउछो किबा स्वीट्स तो सब खाउछो डिफरेंट कलर्स यू आर यूज्ड टू डीकलर ओके few product include paint and spot removers. It is also used in aerosol preparations. Aerosol means you are using deodorants. This is a form of aerosol. Okay. Then dichloromethane. Two chlorine atoms are attached to central carbon. Dichloromethane, DCM or methylene chloride is an organic compound with the formula CH2Cl2. This colorless volatile liquid with a moderately sweet aroma is widely used as a solvent. Although it is not miscible with water, it is miscible with many organic solvents. Okay. Dichloromethane DCM is produced by treating chloromethane with chlorine gas at 400 to 500 degrees Celsius. Okay, this is chloromethane plus chlorine. At the temperature 400 to 500 degrees Celsius, it will form dichloromethane plus HCl. And what are the uses? Dichloromethane is useful solvent for many chemical processes. It is widely used as a paint, striper and degreaser. In the food industry, it has been used to decaffeinate coffee and tea, as well as to prepare extracts of hop and other flavorings. Tomorrow coffee ta kono originally se bitter in taste. Okay, to remove the bitter property, we have to use the dichloromethane, used as a blowing agent for polyurethane foams. Okay, then it is also used in soap manufacturing. जूता तैयारी पई मध्य एथरे यूज होची. It is a solvent in paint removers, degreasing fluids, aerosol propellants and hair कौन लिखा है hair liquors. Okay. Aerosol propellants. Aerosol propellants means if you push the valve of the deodorant, ELS spray is an automatic spray because of presence of propellants. Likewise, in the LPG, liquefied petroleum gas, how it can be liberated out? Because along with LPG, some propellants are there. The propellants are helpful for the release of liquefied petroleum gas, or the propellants are helpful for release of medicaments. Okay, jimti ki jo manku kon asthma heithibo, what do you mean by asthma? Difficulty in breathing. जो मैंने निश्वास नहीं से को कौन so they are using aerosols. In the aerosols, some propellants are there. They are helping to release the medicaments from the bottle to the outside through the nozzle. Okay. Then tetrachloromethane. 4 chlorine atom. At the center the carbon atom is there. Tetra means 4. It is also known as carbon tetrachloride, CCl4. It was formerly used in fire extinguishers as a precursor to refrigerants and as a cleaning agent. It is colorless liquid with a sweet smell that can be detected at low levels. It is mainly produced from methane plus 4 chlorine molecule. Okay, then CCl4 plus 4 HCl. Uses: carbon tetrachloride was used to produce the chlorofluorocarbon refrigerants. It is mainly used as refrigerants. Okay. Then carbon tetrachloride has also been used in the detection of neutrinos. Okay. It is useful solvent for halogenation. For halogenation reaction, it is used as solvent. Carbon tetrachloride was used as a dry cleaning solvent and metal degreasing solvent. Carbon tetrachloride is one of the most potent hepatotoxins. It will produce toxic to the liver cell or hepatic cell, toxic to the liver, so that it is widely used in scientific research to evaluate the hepatoprotective agents. Okay. Whatever the drugs we are discovering, anti-diabetic drugs or hepatoprotective drugs, first we have to induce the diabetes. First we have to trial for preclinical tests. That means in case of mice, in case of rabbits, some drugs are used to induce that type of disease. For example, streptozotocin, aloxan, these are the agents that are inducing diabetes. In case of rat, in case of mice, in case of rabbits. First we have to induce the disease. Then we have to cure by using the test drugs or standard drugs. This is the process of research. Okay, how we can evaluate, how we can discover the new drugs. How we can discover? First we have to induce some type of diseases. For example, diabetes. How the diabetes can be induced? By using aloxan or streptozotocin. These are the two agents that are induced, that will help for the induction of diabetes. Then after induction, it will be treated by any type of standard drugs. What are the different standard drugs used for diabetes? Metformin, then sulfonylurea, biguanides. Different drugs, many types of drugs are there. Nowadays, many drugs are available for treating the diabetes. Allopathic medicines are there. Okay. Now, first we have to induce the disease. Then we have to treat. दिस इज द फंक्शन ऑफ साइंटिस्ट तुम सब जन जन साइंटिस्ट हो कि नहीं हम तो यस देन आड ओके